So this video where I'm going to talk about magnetic forces on charged particles, and this is covered in chapters 30-8 and 30-9. Okay, so the force. So if you have a moving charged particle and there's a magnetic field, so the moving charged particle will experience a force. And that force, so the force from the magnetic field is equal to the charge on your particle times the velocity of the particle v cross product with the magnetic field B. Or if you think in terms of magnitude, if you remember how the cross product works, well, it's the magnitude of one times the magnitude of the other times the sine of the angle in between them. So QVB sine phi. So in the presence of both, so let's say we have both electric and magnetic fields, well then you'll feel a force from the electric field and a force from the magnetic field, and that's called the Lorentz force. And remember, for the electric field, the force is just the charge times the electric field, but then for the magnetic field, we have this V cross B. Now, an interesting thing to notice here, so remember I pointed out this is on a moving charged particle. So if your charged particle isn't moving, so if V equals 0, then even if it's a charged particle, but it's at rest in some region where there's a magnetic field, the force is still 0. Okay, so what does this mean? Well, if you have a charged particle in some region where there's a magnetic field, and we'll pretend there's a constant magnetic field. So this is actually the green lines here are constant magnetic field lines. Well, the force you end up with, well, let's see. So you take V cross product with B. So the direction of the force is actually always pointing in. So as it turns out, this magnetic force is exactly what you need to supply a centripetal force. So if you have charged particles in a region where there's a constant magnetic field, they'll move in a circle. Or it'll be a helix if there you have a component of the velocity in the direction of the field. So, and the radius of this, if you do a little bit of algebra, so you can figure out that the radius has to be m times v, so the momentum divided by the charge times the magnetic field. And if you can do more complicated things, of course. So interesting things like here, this is known as a magnetic bottle. So now our magnetic field isn't quite constant anymore. So it actually gets weaker here in the middle and stronger at the edges. So what'll tend to happen, so your particle will actually spiral around, but it'll just kind of go up and down. So in this bottle, so you can actually use it to trap charged particles. Now, another interesting thing to keep in mind is that magnetic forces can't do work. So remember, we had this cross product, this V cross B. So what that says is the magnetic force is always perpendicular to your instantaneous displacement. And if force is perpendicular to displacement, well, that means that there isn't any work done by the magnetic force. And you can actually use this to build something called a mass spectrometer.